Hello, welcome to our presentation, The Track of Research and Development, a Global View. NHK Science and Technology Research Laboratories, STRL, has contributed to the development of a variety of broadcast technologies, including satellite broadcasting, HD TV, digital broadcasting, and super high vision. In the 3 fiscal years from 2018 through 2020, they will move forward with R&D efforts to create new broadcast technologies and the other services in main themes of reality imaging, connected media, and smart production, with goals for 2020 and beyond that for around 2030 to 2040. To talk about these technologies, Dr. Hirokazu Kamoda, the Senior Manager of NHK STRL, will present the latest R&D at the NHK STRL.
Hello Brazil, hello everyone, I'm Hirokazu Kamoda, a Senior Manager at NHK STRL. It's a great honor to be invited and it's great to talk at that experience. I've got only 10 minutes, so I'll begin straight away. Well, firstly, I'm going to introduce our R&D strategies, and then I will talk about the latest R&D, selecting 5 of the many topics that we have been researching. This is depicting a future diverse content viewing styles that we assume. Various devices such as AR, VR, 3D displays, sheet-type displays, and even haptic devices on top of large 8K TV sets will advance and will be available to ordinary homes, so the ways in which viewers consume content will be even more diverse than they are now. We are studying future media that takes in these devices and styles to provide immersive experiences and deep connections among people, as well as trusted and reliable news and information. We call it diverse vision, and to make it reality, we have been moving forward with our R&D plan, which we drew up 3 years ago. In that, we have set up 3 thematic areas of research. The first one is reality imaging, which is research on immersive presentations by advanced 8K, AR, VR, 3D displays, etc. The second one, connected media, is research on enhancing user experience using internet technologies. The third one, smart production, is research on supporting efficient program production and providing universal accessibility. From reality imaging, I will introduce flexible OLED displays first. We have prototyped a 30-inch 4K flexible OLED display. As you see in this picture, this is really flexible. This keeps displaying images while bending like this. The specification and the features are detailed here, but what is important is that this is an important milestone to bring large UHD TV screens into the living room, which must be lightweight and easy to carry around. Flexible displays can also accommodate diverse viewing styles because they can fit onto various objects owing to their flexibility. Therefore, they may have a wide range of uses and increased points of contact with media content. The second topic from the reality imaging is advanced digital terrestrial television broadcasting. As we explained in last year, the features are increased transmission capacity by adopting higher order modulation, a wider bandwidth, LDPC error correction coding, and so forth. A UHD TV service using the latest video and audio coding, and converging broadcast and broadband by advancing MMT-based IP transport. The progress from last year is that we have expanded field trials to test performance in different environments using transmission sites newly launched by the Ministry of Internal Affairs and Communications. Next, as the final topic in the theme of reality imaging, I will introduce a space-sharing content viewing system utilizing VR and AR that enables viewers to view and share contents as if a person in a distant location is together with them in the same room. A viewer, for example, can experience VR images of an aquarium with the feeling that a friend in a distant location is sitting beside them. 3D images of the friend in a distant location are combined with aquarium VR images, which are projected onto the viewer's head-mounted display, creating an experience that feels like the friends are together at the aquarium. This is an overview of the system. The 3D images of the friend in the distant location are captured in real time using camera with a depth sensor and then transmitted to the viewer in the form of point clouds. Similarly, 3D images of the viewer are also captured, sent to the friend, combined with the aquarium VR images and displayed. Thus, the two people can view the same content while communicating with each other by conversation, hand gestures, and body language. This space sharing notion is important in our future media concept because this will offer stronger bonds among family members and friends even if they are in remote locations. Next, I will introduce a topic from the connected media, which is a content presentation-based technology for a new TV experience with IoT devices. This technology presents content to both TV and various IoT devices according to the viewer's intention, situation, and environment. The IoT control framework enables IoT devices to operate autonomously according to the content, device, and human information. The broadcaster provides content information, for example, the title, time code, and scene information. Then IoT devices such as smart mirror, smart speaker, and a smartwatch present content using their function and the situation or state of the viewer. So this framework enables broadcaster to reach as many users as possible even when they are not in front of the TV. This framework also expands and enriches the ways to present content using IoT devices that surround the TV set. Finally, I will introduce a topic from the research theme of smart production, which is automated sign language CG generation for live sports programs. Ideally, a public service media would provide sign language interpretation for all programs, enabling hearing impaired viewers to enjoy every aspect of the content, but securing sufficient sign language interpreters for all programs would be impractical. This led us to carry out R&D on automatically generated sign language CG animation. NHK STRL is currently developing automated sign language CG generation system for live sports programs using the game data provided in real time. This is a generation process for live sports programs. The system uses real-time game data provided by the event organizers and the like. Once the system receives game data, it extracts data such as player's name, elapsed time, scores, and penalties, and inserts them into the prepared templates of sign language sentences. Then sign language animation is generated from the completed sentences with pre-recorded sign language motion capture data. This is performed in real time to convey the game status and progress. Both the video and the sign language are presented on the same screen together with the associated game data for a higher visibility of the relevant information at a glance. We are also trying to improve the CG avatar quality and expressive power to provide more natural and humane sign language. In sign language, movements other than those of fingers, such as slight movements of the eyes and the eyebrows and facial expressions around the mouth, also play an important role in expression. This video shows a sign language CG avatar that has been improved by synthesizing slight movements and the newly captured skin texture. At this point, the real-time rendering of this quality is not possible, but we expect to provide this quality in live programs in the future. That's all from my presentation. I have given a brief explanation of our R&D strategies and introduced 5 selected research topics. Since I didn't have enough time to introduce other topics that we have, I would like you to visit our online exhibition website, where we present more research topics with videos and photos. Please enjoy this exhibition. Thank you for your attention. We are continuing R&D to shape the future of media. I hope to see you in person next year. Have a good day and have a nice set experience.
Kamoda-san, thank you for your time to share your researches with us. Thank you for watching our presentation. If you have any questions for our speaker, contact him through his email address. I hope to see you in the next episode of Research and Development, A Global View.